1 second. And which can be molded as a rectangular channel. Okay, the die can be molded as a rectangular channel with a thickness of 2L. So if it is a rectangular channel, so the thickness is 2L and 1.6. So I would say 2L equals to 1.6 millimeter, and the width of 20 millimeters and the length of 250 milliliters. So let's calculate the volume. So thickness times width times L, 1.6 times 20 times 250. What do you guys get? Do you get 8,000 millimeter cubed? This is going to help us because we are interested in Q. Later down the road, you will see in the find the minimum screw. The data has been provided here. I'm going to use all the data, but let's go to the question is asked, what is the RPM of the screw? So if I find VZ, then I know V equals to R omega, right? R omega, and if I find omega, which is equal to V over R, and R is the radius of the barrel. The barrel is 35 millimeter in diameter, and we can find, and from there we know N equals to, so I would say, let me write down, omega equals to 2 pi N over 60. So N equals to 60 times omega over 2 pi. So I'm going to use these formula later down the road to find out RPM. So my main objective is to find out VZ, because I know my remaining the data, the remaining data is given in the formula. So let's find out what is Q. In order to find Q, we know that Q is the discharge or the flow volume, volume divided by time. And time is the, I will say, the the cooling time for the part. We can find out using this formula. So it will give the maximum time to prepare the short. So I'm going to use this formula, and then I will use it. I know volume, which is 8,000. I can find out the cooling time, which is the time, maximum time to prepare the short. So I can find out, let's use this 4L square. What is 2L? 1.6. So I can find out, let me write down 2L square. So let me write down 1.6 square converted into meters. So divided by pi square. Alpha is thermal uh, diffusivity, which is equal to alpha equals to K over rho C. K has been given in our data. If you closely look, polymer has a thermal conductivity 0.3 watts per meter per Kelvin. Density has been given, specific heat has been given. So I can plug it in over here, 0.3 divided by 920 divided by 22. This is kilojoules, so I will convert it into joules per kilogram per Kelvin. Okay, now let's plug it in. I want to find out alpha, so let's plug it in over here. Alpha equals to K value, which is equal to 0.3. 0.3 divided by rho. The density of this aluminum is not Sorry, not aluminum, but plastic. 920, 920, and specific heat capacity is 2.2 kilojoules. So convert it into joules per kilogram per Kelvin. So now you will plug it in over here. What do you guys get for alpha? So ln 4 over pi melting point. Melting point is given 220 Celsius is the melting point into the mold TW. The mold has a temperature 50 Celsius and the ejection temperature is 80. So let's plug it in ejection temperature. So I'm going to write down here that the mold temperature, the wall of the mold is 50 degree, ejection temperature is 80 degree. So now you will calculate this. This is my alpha. So if you do the math, the time cooling time to prepare the shot is the time which you will use for finding the Q. It is 3.46 seconds. Can you find it out? Can you verify? Okay, that's good if you have verified this. Now I'm going to use this Q formula. After I find the volume, which is 8,000, so I'm going to use the formula for Q. I'm going to write down here Q equals to volume divided by time. So volume is 8,000 millimeter cubed. Cooling time is 3.46 seconds. So I get 2.31 into 10 to the power negative 6 meter cubed per second. Agreed? So after you find out the flow through the screw into the die, this is a flow through the screw into the die. If both are the same values, so I can use this formula. I'm going to use this formula because my main objective to find Vz. Okay, guys, Vz is the velocity component of the barrel. Suppose if this is my barrel, okay, this is my screw. So this is my screw. The velocity of the barrel or the screw is the same velocity, but it has two components. One is along the helical line. These are the helical lines. Okay, these are the helical lines along the helical lines, and one is perpendicular to the helical line, which is the stirring velocity. So Vz. So if you take a look, this is my theta. So Vz equals to Vb cosine theta. Agreed? So but VZ over here, it's a screw, so don't worry about the barrel. So, and now I'm going to show you, we need to solve for VZ. Let's plug in the values. So 2.31 into 10 to the power negative 0 on the left hand side. The width of the channel, the width of the channel is 45. The flight width is 45 millimeter. So I can write down 45 here, convert it into meters. VZ, what is the channel height? This is channel height. Okay, this this is height over here and the same height on the other side of the screw, and it is given in our data. If you read this data, the flight depth h is 3 millimeter. So I can write down here 3 millimeter, convert it into meters, negative 3 divided by 1000 divided by 2, negative 3 in 10 to the power negative 3 whole cubed. Okay, because this is cubed, so I'm gonna cube it, divide by 12 times eta, which is the viscosity. The viscosity is in the units Pascal second 2.65. So I can write down here 2.65 times the back pressure, the dP, which is given. dP is 350. The back pressure uh, is 350 kilopascal. 350 kilopascal. I want to convert it into Pascal. Divide by dz. Suppose this is the whole channel length. So it's the angle. This is my dz. This is my L. This is my theta. So I can find out L over dz. What is that? Opposite over hypotenuse is sine theta, or dz. That means dz equals to L over sine theta. L is the axial length of the screw, which is how much? It's 1 meter. The whole axial length is 1 meter. So I can write down here 1 meter divided by sine 18. The angle is, so I can write 1 over sine 18 degree in the parentheses. And then you can find out VZ from this. This is just the algebra. This is not difficult for you guys. So if you do the math, you should get 0.095 meters per second. Do you verify that? You verify, you verify. She verifies, he verifies. That's good. Very good, guys. So after you have found VZ, so let me grab this formula. These three formula is gonna one formula is V equals omega R. These are the two formula, not three. So let's use this formula and then plug it in over here. Omega V Z, or that is the divide by the barrel diameter is, the internal diameter of the barrel is 335. So make sure you do the screw. So if this is a screw, this is internal diameter. So this is the barrel. So internal diameter is how much? 35 minus 3. I need this from the center. I need this value. 35. So R is actually the radius of this from the center line to the this value of the screw. 35 divided by 2 and minus 3, the height of the channel. You agree with me? So this is the radius of the screw. This is the radius of the, I'm just zooming it. This is my radius. Agreed? So how much is this? You will plug it in over here. 35 divided by 2 minus 3 is 14.5. Agreed? So if you do the math, omega becomes equal to 0.095 divided by 14.5 into 10 to the power negative 3, which is equal to 6.55 radians per second. Now let's use this formula. Omega equals to 2 pi n over 60. So I can write down 6.55 equals to 2 pi n over 60. From here, n equals to 60 times About 63, right? So this is your answer. Please note it down. I'm zooming out to show you how we solve this question, and please note it down. If you have any questions, you can ask your professor. Okay, let's do one more problem. Everybody has played Legos when they were child. When you were children, you played Legos, right? Me did that too. I built some machines from Legos. So consider fabrication of Lego bricks by injection molding. Each hollow brick has a wall thickness. So let me stop the video recording.